In this video, we're going to look at the project crashing problem, but we're going to do this in Excel. So the project crashing example that we worked out will work only when you have very small problem, and even for small problems the computations can get quite complex when you have multiple critical paths. So instead, if we set this up in Excel, then we can run what is called solver, and the combination, the model and solver, can handle even very large size problems. So we're going to use the same example as the class example that we worked out. So we have activities going from A through G. So we have the normal time, crash time, normal cost, crash cost, and here is the sum of the normal cost, which is 12,300. So now we're going to set this up. So first thing to do is to find crashing cost per week, and for that we need the maximum crashing allowed and the cost difference between the normal cost and crash cost. So MCA is normal time minus crash time. Now the cost difference, CC, stands for crash cost, minus NC is normal cost. So E3 minus D3. Now the crashing cost per week is, you take that and divide by MCA. So now we can copy these three formulas down. Now when we do this, the format gets mixed up, and also there is a 0 divide by 0 error because activity C cannot be crashed. The denominator is 0. So what we're going to do is first erase all the formats. Okay. Then we'll go and put the border back. Okay, you can click that, put the border back, and let's erase this out completely. We don't need that because we cannot crash activity C anyway. Okay. Next is successes. We need successes when we set this part of the Excel model. So remember from the first video, successes for an activity or the activities for which the given activity is predecessor. So for A is predecessor for C and D. So we have C comma D. Okay, let's. Then B is a predecessor only for E, and C is a predecessor for F, and D is a predecessor for E. Now E is a predecessor for G, and F is not a predecessor for anything. So these two are finished. Okay, let me align this properly. All right, now the first table is complete. Now the second table. So remember, we are going to want to crash these activities. Right now we don't know how much crashing we should do, but when we set the model up, we want to identify this range as the range which will contain the week crashed, and we're going to use a program called solver to figure this out. Right now this is blank, but we will act as though there are numbers here. So the actual duration for an activity is the normal time minus any crashing that we may do. So this will be like normal time minus, okay, this is the cell where we will try different values for the amount of crashing we want to do. So B3 minus B13 is the actual duration. Right now this is 0, so the normal time itself is the actual duration. But if we try, like for example, if we try to crash by 1 week, then the actual duration will automatically update to 3. 4 weeks of normal time minus 1 week of crashing. Okay, now copy that, and again see the border gets erased, so let's put the border back. So now we're going to set up the ES and EF. ES is earliest start time, EF is earliest finish time. This is our forward pass. So we need to use the predecessors here. A and B are at the start, so project start time is 0, so that is the start time for both A and B. The finish time is start time plus the actual duration. That will give us the finish time for the activity, and this is the formula for all the activities as far as earliest finish time is concerned. So we can copy that formula right now and put the border back, but the earliest start time is going to depend upon the predecessors. So for C, the start time should come after, so the predecessor for C is A, so only after A is done C can begin, so the finish time of A is the start time for C. And the next activity is D, and D also has A as the predecessor. Next is E. For E we have 2 predecessors, B and D. So we have to take the maximum between B and D, but you don't want to type this in yourself. We want to use the max function, so this process will be automatic. So max between B and D, EF, the earliest finish time between these two. And F is C, the predecessor is C, and for G, predecessor is E. Now the forward pass is complete, so now we can set up the project duration. Project duration is the maximum finish time of the finish activities. So here we have 2 finish activities, which are F and G. So this is maximum finish time of F, finish time of G. And that is the project duration. Now let's do the backward pass. Now for that we need to use the successors. These are the 2 activities with no successors. So you set the project duration as the latest finish time for these 2. Now the start time is the latest finish time minus the actual duration. We're going backwards. So we can copy this to the rest of them because they all have the same pattern. Now let's remove the format. Okay, you can do this by going here to clear and clear formats. Okay. Now the latest finish time for E, okay, E, the successor is G. So G's start time is the finish time. For D, E's finish time, E's start time is the finish time. For C, it's F, so F's start time is its finish time. For B, it is E. Now when we have multiple successors, then we have to use the min function, the minimum start time between C and D. Now that takes us back to 0. Now we can set up slack time as the difference between two finish times or two start times. Either one would do. So let's use the finish time, and we can copy that, and we'll put the border back. So we have A, D, E, G as the critical path. Next, we have to set up the cost. So the normal cost is the sum of the normal cost. So that is our normal project cost. Total crashing cost is how much crashing we're going to do, weeks of crashing, should be multiplied by the corresponding crashing cost per week and summed. And we can use, there is a function in Excel which does that, and that is called sum product. So how many weeks we crashing, comma, cost of crashing per week. So this function will pair each cell in the two ranges, multiply them and sum them. Okay, right now it is 0 because we are not doing any crashing at this point. Then we add these two, and that is our total project cost. This is the model, and what we need to do is to figure out values for weeks crashed such that we achieve the least possible project cost. So that's what we want to achieve, and we will do that using Solver. I'll demonstrate that in the next video.